Hello students, can you hear me? Hello students, last time we have seen the difference between exothermic and endothermic reaction. The reaction in which heat is given out, that is called as exothermic. You know meaning of word exit. Exit means to go out, like that. Exothermic means the reaction in which heat is given out, and endothermic means heat is taken in or heat is absorbed. Okay, so these are the different examples where endothermic reactions are shown. See, when you hear sometimes doctor advise you to heat with the instant cold pack to any injury or any swelling, like that. So that is nothing but the endothermic reaction. It absorbs heat, and so means it is used for, means this ice pack, it is used for heating. That is called as the endothermic reaction, means the principle behind it is endothermic reaction. Then the photosynthesis reaction, that is also endothermic. Cooking egg, that is endothermic reaction. Then dissolving salt in water. When you dissolve salt in water, it absorbs heat. 4 kilojoule heat is absorbed per mole. Okay, so these are different examples of endothermic reaction. Water evaporation means sunlight is absorbed in water or by water, and then water vapors are formed, means that is also the endothermic reaction. Then cooking an egg, baking bread, photosynthesis, these are the different examples of endothermic reactions. Then see the examples of exothermic reaction. When you inhale oxygen inside our body, that carbon means when means that is also exothermic reaction. Then when carbon reacts with oxygen, carbon dioxide is formed. That burning of coal, which is used as a fuel, means coal is used as a fuel, that is exothermic reaction, means at that time we get high amount of the heat. Then formation of ammonia, when hydrogen reacts with nitrogen to give ammonia, that is also exothermic reaction. Then hydrogen reacts with oxygen to form water molecule, that is also exothermic reaction. Sulfur reacts with sulfur dioxide to form sulfur trioxide, this is also exothermic reaction. Then calcium oxide, that is also called as a slaked lime, when reacts with water, means when चुना जेव्हा पाण्यामध्ये डिझॉल्व केला जातो to form calcium hydroxide, that is also exothermic reaction. Then this reaction when glucose is reacts with oxygen, that is respiration reaction. This is the respiration reaction. At that time also heat is evolved and or given out, that is the example of exothermic reaction. Means these are different examples of exothermic reaction in our day-to-day life. Then we'll move to the next. Again, some differentiation between exothermic and endothermic is given. See, photosynthesis, endothermic. Combustion of fuel, exothermic. Baking bread is endothermic. Then candle flame, it is exothermic. Evaporation of water, endothermic. Rusting of iron, exothermic. Cooking an egg, that is endothermic. Melting of ice cube, that is endothermic. And making ice cube, that is exothermic. Like that, there are different examples of exothermic and endothermic reactions. Now the next is thermodynamic standard state. The standard state, or means what is the actually thermodynamic standard state? Standard state means the reference state of a pure compound, means at temperature 25 degrees centigrade and pressure 1 atmosphere. This is called as the standard state of the chemical reaction. Means when concentration is 1 molar, pressure is 1 atmosphere and temperature is 25 degrees centigrade, all these conditions of reaction, those are called as the thermodynamic standard state. For an element in the standard state, 1 atmospheric pressure, 25 degrees centigrade temperature, delta H means the difference between the enthalpies of the product and reactant, that is indicated by delta H. It is indicated by delta H0, means this is the standard enthalpy of the reaction. Delta H means enthalpy of reaction, and delta H0, that is nothing but the standard enthalpy, means this 0 indicates that the reaction the enthalpy change, it is for the standard state. Okay, means this 0, it refers to the standard state of the reaction. Means what is the standard state of reaction? Same, 25 degrees centigrade temperature, pressure 1 atmosphere and concentration 1 mole. These are the standard state of the reactions. Okay, now we'll move to the next slide. Thermochemical equation. What is actually thermochemical equation? Thermochemical equations means this is the balanced chemical equation. As usual, balanced chemical equation means number of atoms present on the reactant side, that is exactly equal to the number of atoms present on the product side. See here, hydrogen atoms 2H2O means hydrogen atoms are 4, 2H2, 2 2s are 4, and here also there are 4 hydrogens. Oxygen, number of oxygen atom is 2, here also number of oxygen 2. So this is the balanced chemical equation. Then what is the thermochemical equation and balanced chemical equation? Means difference between these two. In thermochemical equation, physical states are mentioned. See, these are the physical states. Means this is the important condition of the thermochemical equation. In this reaction, see, water, it is present in liquid state, means the physical state of the water or this reactant is mentioned, and that is the important condition of thermochemical equation. Then this hydrogen, it exists in the gaseous state, means this is also one of the important condition. Then oxygen existing in gaseous state, and the enthalpy of the reaction means the difference between the enthalpies of the product and reactant, it is 572 kilojoules. This for the second example, CH4 plus 2O2 giving CO2 gas plus water, means this is the combustion reaction of methane. In this methane, it is existing in gaseous state, and oxygen also in gaseous state, and carbon dioxide gaseous state, water is also in gaseous state, and delta H for this reaction is minus 802.00, means this much 802 kilojoule of heat is evolved in this reaction. Understood? So this is the thermochemical equation, means here the standard states of the substance are mentioned and delta H value is also mentioned. This is called as the thermochemical equation. Then standard enthalpies of formation. You know the meaning of word formation. Formation means when the compound is formed from its elements. You can take example of suppose कार्बन डायऑक्साइड. कार्बन डायऑक्साइड हे जर आपण एक्झाम्पल कन्सिडर केलं तर कार्बन डायऑक्साइड तयार होण्यासाठी कुठले एलिमेंट्स लागतात, तर कार्बन अँड oxygen, means these two elements are required for the formation of carbon dioxide. Then whatever the enthalpy change taking place during the formation of this carbon dioxide, this enthalpy is known as, means this change in enthalpy is known as enthalpy of formation. Okay, it is indicated by delta HF0, means enthalpy of formation. See, these definitions are frequently asked in your board exam. What is enthalpy of formation? The enthalpy of change for the formation of 1 mole of the substance. This is important condition. 1 mole of substance in its standard state from its component, which are the component of carbon dioxide, carbon and oxygen, in their standard state. Means in their standard state means at normal temperature pressure condition, carbon is in solid state and oxygen in the gaseous state. Means in their standard state, carbon dioxide gas form, it exists in standard state, that is gaseous state. Means this is the enthalpy of formation. Again, I will repeat. The enthalpy of formation is defined as the change in enthalpy for the formation of 1 mole of substance. This is 1 mole of carbon dioxide from its component in their standard state. These are the important conditions. When you write definition, you have to mention there 1 mole of substance is formed from their standard state, from their component in their standard states. Okay. So note down the standard enthalpy of formation of any pure element is 0. Means carbon हा एकच element आहे. Means it is not mixed with any other element. In its standard state, enthalpy of formation of that element is 0, always 0. Okay. Now I will move to the next slide. All these definitions are similar, student. So it is very easy to remember. Next is standard enthalpy of formation. Means examples are given for different reactions. See here, this is the formation of nitrogen oxide gas, NO2 gas, from its component N2, which exists in gaseous state at its standard state, and oxygen also in gaseous state. And the standard enthalpy H0, it is representing or denoting that this is the enthalpy of formation in the standard state. So delta H0F means enthalpy of formation of nitrogen dioxide is 33.18 kilojoule per mole. Means for the formation of 1 mole of NO2, this much amount of heat is required or it is absorbed. Okay. So for the formation of 1 mole of CaO, calcium solid and oxygen gaseous is required, and the enthalpy of formation is minus 63.9 kilojoules per mole. Then when CbR4 means carbon tetrabromide is formed in its standard state, that is in the solid state, graphite means carbon solid reacts with bromine liquid to form CbR4 solid, and the enthalpy of formation is 29.4 kilojoules per mole. Now we'll turn towards the next example, that is the enthalpy of combustion. What is enthalpy of combustion, students? Enthalpy of combustion, it is denoted by delta Hc. C is for combustion and H0 means it is the standard enthalpy of combustion. It is the enthalpy change, means definition for it. Enthalpy change during the reaction when 1 mole of the substance in its standard state is completely burned. Okay. So when the C2H2 in gaseous state reacts with oxygen gas, for balancing we have taken here 5/2 O2 to give 2 CO2 gas plus H2O. Means in this, here 2 carbon atoms are present on the reactant side. So it is obvious that 2 carbon dioxide molecule will be formed because this is completely burned. 1 mole of the substance, when it is completely burned to give carbon dioxide and water, the heat is evolved, and that heat evolved is known as enthalpy of combustion. And for this reaction, the enthalpy of combustion is minus 1300 kilojoule per mole. See the definition. Enthalpy or heat of combustion is the enthalpy change for the complete burning of 1 mole of the substance, and it is means this reaction is carried out under standard conditions. Standard condition, I will again tell you, this C2H2 in gaseous state, oxygen in gaseous state, carbon dioxide in gaseous state. These are the standard conditions. So one more example is given. When C6H12O6 in solid state, it is completely burned to give carbon dioxide and water. In this reaction, or the enthalpy of combustion of this substance is 2808 kilojoule per mole. Okay. Now we'll turn towards the next slide. See the bond enthalpy. What is bond enthalpy? See, when any bond, when it is broken, means suppose this is the bond between the two atoms of hydrogen and it is hammered, then two hydrogen atoms will get separated in the gaseous state. See, this is one of the hydrogen and this is another hydrogen atom. Means the enthalpy or the energy change required to break the particular bond. This is the bond between two hydrogen atoms. See, here one hydrogen atom is there, and here the another hydrogen atom is there, and this particular bond, or to break this particular bond between two hydrogen in gaseous state, means 1 mole of hydrogen, when it is broken to give hydrogen atoms, this is known as the bond enthalpy. I'll again repeat. The enthalpy change required to break the particular covalent bond in 1 mole of the gaseous molecule to produce gaseous atoms. This is called as the bond enthalpy. Means when this hydrogen molecule is broken down to give two hydrogen gaseous atoms, the enthalpy required or the energy required to break this bond is 436 kilojoules per mole. It shows that HH bond in 1 mole of the H2 gas is decomposed to produce gaseous hydrogen atoms, and this energy required to break this particular bond is known as bond enthalpy. Hope you have understood what is bond enthalpy. Now we'll move to the next slide. What is average bond enthalpy? We'll see here. See, the water molecule in gaseous state, it breaks to give 2 hydrogen and 1 oxygen atom. But these 2 bonds present in water molecule means which 2 bonds? See, this is water molecule, means 1 hydrogen, then oxygen in the center, and 1 more hydrogen. This is the structure of water molecule. But means here 2 OH bonds are there. Suppose this is what bond number 1, means this is one of the bond between oxygen and hydrogen, and this is the second bond present between oxygen and hydrogen. म्हणजे 2 OH बॉन्ड आहेत वॉटर मॉलिक्यूल मध्ये, एक हा पहिला जर आपण कन्सिडर केला आणि हा दुसरा, तर या दोन्ही बॉन्डला ब्रेक करण्यासाठी लागणारी एनर्जी जी आहे ती वेगवेगळी आहे. मीन्स द व्हॅल्यू ऑर अमाउंट ऑफ एनर्जी रिक्वायर्ड टू ब्रेक दिस बॉन्ड between oxygen and hydrogen, it is different. Means the energy required for both the bonds is different. Means this takes place in case of the polyatomic molecule, म्हणजे जिथे जास्त atoms present असतात अशा molecule मध्ये बॉन्ड ब्रेक करण्यासाठी, बॉन्ड जरी सेमच असले, म्हणजे दोन्ही बॉन्ड सेम आहेत OH आणि OH, तरी सुद्धा इथे बॉन्ड ब्रेक होण्यासाठी लागणारी एनर्जी वेगवेगळी आहे. And in such cases the average of these 2 bonds, it means that is considered, and that is known as the average bond enthalpy. Okay, see, it shows that the total enthalpy change 927 kilojoule. There are 2 OH bonds. This is first OH bond and this is second OH bond, which are identical. हे दोन्ही बॉन्ड आयडेंटिकल आहेत, तरीही बॉन्ड एनर्जी वेगवेगळी आहे. So the average bond enthalpy for such bond is used, and it is nothing but the average जसं आपण मॅथ्स मध्ये ऍव्हरेज काढतो तसंच ऍव्हरेज इथे काढलेलं आहे. 927 divided by 2 because 2 bonds are present. So the average of this is 463.5 kilojoules. Means average bond enthalpy for this OH bond is 436 kilo. Sorry, it is not for average of this. You can calculate 436 or 63. Okay, and means this is the average bond enthalpy. Now we'll move to the next. Enthalpy of the reaction. In the chemical reaction, reactant bonds are broken and the product bonds are formed. म्हणजे कुठलीही केमिकल रिएक्शन होत असताना काय होत असतं, तर रिएक्टंट्स मध्ये असणारे बॉन्ड हे ब्रेक होतात आणि प्रोडक्ट मध्ये नवीन बॉन्ड तयार होतात. फॉर एक्झाम्पल वी कॅन टेक हिअर दिस एक्झाम्पल. दिस हायड्रोजन molecule, it is reacting with this iodine means I2. ओके, म्हणजे इथे दोन हायड्रोजन मध्ये एक बॉन्ड आहे आणि या दोन आयोडीन मध्ये बॉन्ड आहे आणि यांची दोन्हींची रिएक्शन झाल्यानंतर इथे काय तयार होत आहे, HI हायड्रोजन आयोडाइड. मीन्स दिस बॉन्ड बिटवीन हायड्रोजन हायड्रोजन इज ब्रोकन डाऊन. हा बॉन्ड ब्रेक होत आहे आणि हा सुद्धा बॉन्ड आयोडीन मधला बॉन्ड ब्रेक होत आहे आणि इथे नवीन बॉन्ड कुठला तयार झालाय, तर हायड्रोजन आणि आयोडीन यांच्यामध्ये बॉन्ड तयार झालेला आहे. मीन्स इन केमिकल रिएक्शन reactants bonds are broken and product bonds are newly formed. So the enthalpies of the reaction, म्हणजे इथे या रिएक्शन मध्ये जो काही एन्थाल्पी मध्ये एनर्जी मध्ये काही चेंज होणार आहे, that is nothing but the so the enthalpy of this reaction having the covalent bonds are calculated by knowing the bond enthalpies of the reactants and products. So it is assumed that all the bonds are identical. Enthalpy change for the reaction, it is calculated by this formula. Enthalpy change for the reaction, it is represented in this way. Delta H0 of R means enthalpy, standard enthalpy change for the reaction. This R, it is representing the enthalpy of the reaction. It is nothing but the difference between the enthalpies of the reactants minus product. पहा, रिएक्शनचा एन्थाल्पी कॅल्क्युलेट करण्यासाठी सगळ्या रिएक्टंटच्या एन्थाल्पीची सम केली जाते, म्हणजे बेरीज केली जाते, ऍडिशन केली जाते. त्यामधून प्रोडक्टच्या सगळे प्रोडक्ट जे असतील त्यांच्या एन्थाल्पीची सम केली जाते आणि या दोन्हींमधला डिफरन्स काढला जातो. मीन्स समेशन ऑफ द एन्थाल्पीज ऑफ द रिएक्टंट minus summation of enthalpies of the product is nothing but the enthalpy or the standard enthalpy of the reaction. Means this is calculated by this formula and numericals are asked based on this formula many a times in your board exam. Okay, see, in this way formula can be used. Enthalpy of the reaction means about this reaction, it is nothing but the summation of the enthalpies of these हायड्रोजन हायड्रोजन अँड आयोडीन आयोडीन यांच्या दोन्हींची सम करून यामधून मायनस केलं जाते HI ची सम. सो देर आर 2 HI molecules, so multiply by 2 to this HI bond enthalpy and get the difference between this. It will give you the enthalpy of the reaction. Hope you have understood. See, this is important law from this topic, this that is the Hess's law of constant heat summation. So what is Hess's law of constant heat summation? Now, first we will see the statement. Enthalpy change for the reaction is equal to the sum of the enthalpy changes for the individual steps, or it can be stated as the enthalpy change for any reaction is same whether the reaction takes place in single step or in multiple steps. म्हणजेच काय, तर एखादी रिएक्शन पहा, आपण इथे एक्झाम्पल कन्सिडर केलेला आहे फॉर्मेशन ऑफ अमोनिया गॅस. सो in this means there are two methods for the formation of ammonia. One method or the first method we can consider हायड्रोजन रिएक्ट्स विथ नायट्रोजन टू गिव्ह डायरेक्टली अमोनिया इन अ सिंगल स्टेप. पहा इथे जे एक्झाम्पल आपण कन्सिडर केलेलं आहे, अमोनिया तयार होण्याची जी रिएक्शन आहे ती पहिल्या प्रकारामध्ये आपण डायरेक्टली अमोनिया तयार करतोय एकाच स्टेप मध्ये. मीन्स नायट्रोजन रिएक्टिंग विथ हायड्रोजन टू गिव्ह अमोनिया, and in this reaction the enthalpy change is minus 92.2 kilojoules per mole. म्हणजे 1 मोल अमोनिया तयार होण्यासाठी इथे 92.2 किलोजूल एवढी हीट ही इव्हॉल्व होते. मीन्स दिस रिएक्शन इज एक्झोथर्मिक. मायनस साइन इज इंडिकेटिंग दॅट द रिएक्शन इज enthalpy is negative or heat is evolved in this reaction. आता हीच रिएक्शन आपण वेगळ्या प्रकारेही कॅरी आउट करू शकतो. मीन्स फॉर्मेशन ऑफ अमोनिया कॅन बी डन इन 2 स्टेप्स. इन फर्स्ट स्टेप हायड्रोजन रिएक्ट्स विथ नायट्रोजन टू गिव्ह this N2H4 and the enthalpy change for this reaction is 95.4 kilojoule. Then in the another reaction N2H4 means this is the intermediate product form in the first step. या स्टेप मध्ये हे तयार झालेला जो काही इंटरमिजिएट प्रोडक्ट आहे तो सेकंड स्टेप मध्ये परत पुढच्या हायड्रोजन मॉलिक्यूल बरोबर रिएक्ट होऊन आपल्याला अमोनियाचा मॉलिक्यूल मिळतो. म्हणजे सेम रिएक्शन production or formation of ammonia, it is done in 2 steps by the second method, and in the first step this reaction is carried out in single step. आता पहा दोन्ही रिएक्शन मध्ये जो काही एन्थाल्पी चेंज होतो आहे, पहा पहिल्या स्टेप मध्ये इथे एन्थाल्पी जो आहे रिएक्शनचा तो आहे +95.4 and for the second reaction enthalpy change is -187.6. आणि या दोन्हींची जर आपण सम केली, एक नंबर मायनस आहे एक नंबर प्लस आहे, निगेटिव्ह आणि पॉझिटिव्ह यांची ऍडिशन करत असताना आपण काय करत असतो तर मोठ्या नंबर मधून छोटा नंबर मायनस करतो आणि जो काही मोठा नंबर आहे त्याचा साइन देतो आपण. तर यांच्यामधला जो डिफरन्स म्हणजे यांची ऍडिशन जी येते ती किती आली आहे 92.2 किलोजूल्स. म्हणजेच या दोन्ही रिएक्शन मध्ये होणारा एन्थाल्पी मधला जो काही चेंज आहे तो सेम आहे. Although the reaction is carried out in single step or in multiple step, the enthalpy of the enthalpy change of the reaction is same whether the reaction takes place in single step or in multiple steps. हाच हेजेस लॉचं स्टेटमेंट आहे. मीन्स हेजेस is one of the scientists who has told that the enthalpy change during the reaction is same whether the reaction is taking place in single step or in multiple steps. ओके, म्हणजेच रिएक्शन एका स्टेप मध्ये झाली किंवा अनेक छोट्या छोट्या स्टेप्स मध्ये झाली तरी टोटल एन्थाल्पी चेंज जो काही होणार आहे रिएक्शन मध्ये तो तेवढाच असतो जो की सिंगल स्टेप रिएक्शन मध्ये होतो तेवढा. ठीक आहे. सो दिस इज हेजेस लॉ. नाउ the same is diagrammatically shown. Means Hedges law has been shown in diagrammatic way. In the first method, reactant A means general reaction dili hai, A is giving product D, and in the second method means this reaction is taking place in multiple steps. In first step A is giving B, then in the second step B is giving C, B is giving C, and in the third step C is giving D, and this is the single step reaction. And when we consider the enthalpy change for the reaction A to B is delta H1, B to C is delta H2, then C to D is delta H3, and when you add all these three, it gives you the enthalpy change that is delta H, which is exactly equal to the direct or single step method. म्हणजेच दोन्ही रिएक्शन मध्ये होणारा एन्थाल्पी मधला जो काही चेंज आहे तो सेम आहे वेदर रिएक्शन इज टेकिंग प्लेस इन सिंगल स्टेप और इन मल्टिपल स्टेप. मीन्स दिस इज द डायग्रामेटिक रिप्रेझेंटेशन ऑफ हेजेस लॉ विथ द हेल्प ऑफ जनरल रिएक्शन, जे की तुम्हाला एक्झाम मध्ये द्यायचं असतं. मीन्स याच्यावरती क्वेश्चन विचारला जातो परीक्षेमध्ये. State and explain Hedges law of constant heat summation. Then next is applications of Hedges law. What are applications? Hedges law, it is useful to calculate the enthalpy change for the reaction with their enthalpies being not means enthalpy changes for the reaction with their enthalpy being not known experimentally. म्हणजे एखादी रिएक्शन असते की जी डायरेक्टली होत नाही, मल्टिपल स्टेप्स मध्ये त्याचे जे काही एन्थाल्पी मध्ये बदल होणार आहे त्या सगळ्यांची ऍडिशन केली की त्या रिएक्शनचा किंवा त्या एक्सपेरिमेंट मध्ये होणारा एन्थाल्पी चेंज आपल्याला कॅल्क्युलेट करता येतो. अँड दॅट इज वन ऑफ द ऍप्लिकेशन ऑफ हेजेस लॉ. Then it is useful to determine the enthalpy of the reaction which do not take place in single step. Means these are the applications of Hege's law which can be asked in your board exam. Then another point of this topic is spontaneous processes. What is the spontaneous process? The process which takes place on its own, that is called as spontaneous process. तुम्हाला स्पॉन्टेनियस मीनिंग माहिती आहे स्टुडंट. स्पॉन्टेनियस मीन्स जी स्वतःहून होते एखादी प्रोसेस त्याला आपण स्पॉन्टेनियस म्हणतो. विदाउट द इन्फ्लुएन्स ऑफ द एक्सटर्नल फोर्स सच प्रोसेस इज नोन ॲज स्पॉन्टेनियस प्रोसेस. सो वॉटरफॉल आपण सगळ्यांनी पाहिलेला असेल तर तो वॉटरफॉल काय होत असतं तर वरून पाणी उंचावरून खाली पडत असतं. मीन्स विदाउट द एक्सटर्नल इन्फ्लुएन्स और विदाउट अप्लाइंग एनी अदर एक्सटर्नल फोर्स water falls from high hills to downward levels. This is the spontaneous or example of the spontaneous reaction. Then lump of sugar dissolved in cup of coffee, that is also spontaneous reaction. 1 atmosphere means at 1 atmospheric pressure water freezes. या टेम्परेचरला 0 डिग्री सेंटीग्रेड टेम्परेचरला वॉटरचं फ्रीजिंग होतं म्हणजेच आईस फॉर्मेशन होतं. ही सुद्धा रिएक्शन कशी आहे स्पॉन्टेनियस आहे. Heat flows from hotter body to colder body, that is also example of spontaneous process. Means all these are the spontaneous processes. A gas expands in evacuated tube. Iron exposed to oxygen and water forms rust. म्हणजेच पावसाळ्यामध्ये लोखंडाच्या वस्तू गंजतात. या सगळ्या रिएक्शन किंवा हे सगळे एक्झाम्पल्स आपल्याला काय सांगतात तर या सगळ्या रिएक्शन्स कशा आहेत स्पॉन्टेनियस आहेत. विदाउट any external influence, the process when it takes place on its own, such a process is known as spontaneous process. Blooming of the bud, कळीचं फुलामध्ये रूपांतर होतं. This process is also spontaneous process. Then hatching of the egg, egg मधून पिल्लू बाहेर येतं, that is also the spontaneous process. In this way these are the different examples of spontaneous process. In chemistry also spontaneous process is having same meaning. The process which takes place on its own without any external influence is called as the spontaneous process. Now what is the relation between energy and spontaneity student? तर स्पॉन्टेनिटी म्हणजे काय किंवा स्पॉन्टेनियस रिएक्शन कधी होते, एनर्जीचं आणि स्पॉन्टेनिटीचं काही रिलेशन आहे का तर ते आहे. Entropy, it is the measure of the randomness or disorder of the substance. Entropy ही एक नवीन टर्म आहे आपल्या थर्मोडायनामिक्स मधली आणि ही डिनोट करण्यासाठी एस हे लेटर वापरलं जातं. मीन्स एंट्रॉपी इज डिनोटेड बाय लेटर एस. एंट्रॉपीलाच काय म्हटलं जातं किंवा एंट्रॉपीलाच आपण सिंपल इंग्लिश लँग्वेज मध्ये डिसऑर्डर असं म्हणू शकतो किंवा रँडमनेस. That is also orderly arrangement आणि randomly arrangement किंवा orderly arrangement and disorder हे तुम्हाला सगळ्यांना समजत असेल. म्हणजेच आपण एखाद्या लग्नाला गेल्यानंतर पाहतो सुरुवातीला गेल्या गेल्या आपल्याला सगळ्या चेअर्स अगदी व्यवस्थित लाईन मध्ये हॉरिझॉन्टल आणि व्हर्टिकली अलाइन केलेल्या असतात, त्या अगदी व्यवस्थित अरेंज केलेल्या असतात. पण काही वेळानंतर आपण पाहतो एखाद्या तासानंतर किंवा लग्न लागल्यानंतर पाहतो तर आपण सगळ्या चेअर्स या उलट्या सुलट्या कशाही फिरवलेल्या असतात, कुठलीही त्यामध्ये ऑर्डर नसते. म्हणजे सुरुवातीची जी अरेंजमेंट आहे ती कशी आहे ऑर्डरली अरेंजमेंट आणि नंतरची जी काय आहे ती रॅन्डम अरेंजमेंट किंवा त्यालाच आपण डिसऑर्डर म्हणतो. तर स्पॉन्टेनियस प्रोसेस इन्क्रीजेस द एंट्रॉपी ऑफ द युनिवर्स. म्हणजे स्पॉन्टेनियस एखादी प्रोसेस होते म्हणजेच काय होत असतं तर एंट्रॉपी मध्ये वाढ होत असते म्हणजे डिसऑर्डर वाढत असते. नॅचरल थिंग्स टेंड टुवर्ड्स द डिसऑर्डर. इट कॅनॉट बी मेजर्ड डायरेक्टली. आपल्याला एंट्रॉपी डायरेक्टली मेजर करता येत नाही, पण त्यांच्यामधला फरक मेजर करता येतो. मीन्स एंट्रॉपी इट इज द स्टेट फंक्शन. सो S1 it is the entropy in initial state, and if S2 is the entropy in the final state, then the difference between these two entropies means S2 minus S1, it is nothing but delta S. So this delta S is the change in enthalpy, or sorry, not enthalpy, it is change in entropy, and it is the state function, and this is known as the spontaneity. It can be used to predict spontaneity of the reaction, and spontaneity is usually measured in joules per Kelvin. Okay. See the different examples of spontaneous reaction or spontaneous processes. When ice, पहा आपण पाहतो आईस म्हणजे सॉलिड स्टेट आहे वॉटरची. यामध्ये जे सगळे पार्टिकल्स आहेत, ॲटम्स आहेत, ते सगळे ऑर्डरली एकमेकांपासून अगदी ऑर्डरली अरेंज केलेले आहेत. मीन्स हिअर दिस डेल्टा एस इज लेस. आणि आईस जेव्हा मेल्ट होतो तेव्हा वॉटर फॉर्म होतं, आणि तेव्हा आपण पाहतो की हे सगळे पार्टिकल्स यांची अरेंजमेंट कशी आहे, डिसऑर्डर आहे, इथे ऑर्डरली अरेंजमेंट नाहीये. म्हणजेच इथे एंट्रॉपी वाढलाय. सॉलिड मधून लिक्विड मध्ये कन्वर्ट होत असताना एंट्रॉपी मध्ये वाढ झाली आहे. तसंच लिक्विड स्टेट मधून गॅसियस स्टेट म्हणजे वॉटरला आपण या हीट दिली तर याचा गॅस फॉर्म होईल, आणि इथे जे काही पार्टिकल्स थोडेफार ऑर्डरली आहेत तर ते आता या आणखीन जास्त डिसऑर्डर यांच्यामध्ये आपल्याला दिसते, एकमेकांपासून लांब लांब गेलेले दिसतात. म्हणजेच इथे एंट्रॉपी मध्ये वाढ झालेली आहे. सी एंट्रॉपी इज इन्क्रीजिंग इन दिस वे. एंट्रॉपी इन सॉलिड स्टेट इज लिस्ट. सगळ्यात कमी एंट्रॉपी कुठे आहे, म्हणजेच सगळ्यात कमी डिसऑर्डर कुठे आहे तर सॉलिड स्टेट मध्ये. लिक्विड मध्ये डिसऑर्डर वाढली आहे ऍज कम्पेअर टू सॉलिड्स, अँड गॅसियस स्टेट मध्ये डिसऑर्डर आणखीन जास्त वाढली आहे ऍज कम्पेअर टू लिक्विड. इन दिस वे disorder is increasing from solid to liquid to gaseous states, which is the more disordered. Gaseous state is most disorder and solid state is least disorder. Means entropy is least in solid state and entropy is highest in gaseous states and intermediate in the liquid states. Then quantitative definition of the entropy. An entropy change of the system is equal to the amount of heat transferred. Heat आपण denote करतो Q ने. In the reversible manner, means this Q reversible, to it a reversible manner divided by the temperature in Kelvin. म्हणजेच डेल्टा एस जो काही एंट्रॉपी मध्ये चेंज होणार आहे तो आपल्याला जर काढायचा असेल तर इट कॅन बी डिटरमाइंड विथ द हेल्प ऑफ दिस फॉर्म्युला. डेल्टा एस इज इक्वल टू Q reversible divided by temperature in Kelvin. Delta S is equal to Q reversible divided by T, that is the temperature in Kelvin. Q reversible, Q म्हणजेच हीट आहे, ती जूल्स मध्ये डिनोट केली जाते. मीन्स हीट ही एक एनर्जी आहे, ती जूल्स मध्ये दिली जाईल, आणि टेम्परेचर हे केल्विन मध्ये. म्हणजेच ही डेल्टा एस युनिट्स काय आहेत तर जूल्स पर केल्विन. Entropy, it is the state function, and difference between the entropy or the change in the entropy is quantitative definition of entropy is given by this formula, and it is useful for solving the numericals. पहा तुम्हाला डेल्टा एस जर कॅल्क्युलेट करायला सांगितला एक्झाम मध्ये म्हणजे न्यूमरिकल असेल तर त्याचा फॉर्म्युला काय आहे, डेल्टा एस इज इक्वल टू क्यू रिव्हर्सिबल डिवायडेड बाय टेम्परेचर और टेम्परेचर इन केल्विन. नाउ this is all about the thermodynamics topic, student. Numericals are left. I will send it to you, and when we will get chance I will also take one more lecture about this. Means याचे numericals मी एक lecture घेऊन घेणार आहे. In this way we have completed this topic, thermodynamics. If you have any doubt, student, you can ask me anytime on my WhatsApp number. समजलंय का thermodynamics topic सगळ्यांना? हरीश, मृगांक, Rutuja. Hope you have understood this thermodynamics. If you have any doubt, you can ask me anytime. Okay. Bye, students.